Hello and welcome back again to our channel. And today we are going to look at equations, the topic that gets many people scary the most. But today we are here to prove that equations are easy. So if you join us today, welcome back again to the channel. If you haven't yet subscribed, please do us a favor by subscribing. In this video, we are going to look at equations, and we're going to start off by looking at the introduction. We're going to look at some kind of introduction to algebraic expression. We want to get that one out of the way. Algebraic expressions, and then from there we'll zoom straight into types of equations. We'll look at types of equations. Yeah, there are different types of equations. So we're going to look at the types of equations, and then we're also going to look at the linear. We're going to start off with the linear equation, the linear type of equation, and then we'll introduce that. We'll introduce that first, and then after introducing that, the next thing we're going to do is look at slope, how to determine or how to calculate a slope or a gradient, how to calculate a slope or a gradient, yeah, or a gradient, and we'll compare that. With differentiation. We'll compare that with finding the purpose behind differentiation and then a slope or a gradient. And then once we do that, we'll look at what we call the intercepts. We'll look at how to determine intercepts of a line, intercepts and equations of a line, because we need the intercepts to be able to at least ascertain what the equation of a line is. So intercepts and equation of a line. And then once we are done with that, we'll go straight into polynomials. We'll look at polynomials, because after looking at linear equations, the next thing to do is to look at polynomials, and we'll introduce that first. And then after introducing that, we'll go into what we call quadratic equations. We'll look at quadratic equations, and then we'll look at the three methods, of solving quadratic equations, quadratic equations. And then after that, we'll look at simultaneous equations. Equations. Today's video is going to be very comprehensive, so that you get to have everything that you need to know about equations. So that it's not in piecemeal. Then we'll also look at what we call the change. We'll look at what we call the change of subject. And then maybe after the change of subject, we'll come and look at inequalities. Yeah, inequalities, and then we'll end it with variations. We'll end the day with variations. Yeah, I know it looks a lot taller, but we are going to do it very quick. We'll touch on everything quickly, and I think everything will look perfect. Yeah. So these are the things we're going to be looking at for today's in today's video. So let's start off with algebraic expressions. So with algebraic expressions, we said that it's propounded by Francois Viette. So we have what we call algebraic expressions. I think it depends on the school you and I went to, or probably the country that we live in. So so it was propounded. Algebraic expressions were propounded by Francois Viette, I think a French mathematician, in the year 1900 to 1600 BC, before Christ. And we said that, this is very important. Algebraic expressions is very important because it helps us be able to analyze numbers and variables together. It helps us to be able to analyze numbers and variables. So algebraic expressions, by definition, the definition, we can say that it's an expression. Algebraic expression is an expression that involves numbers. And at the same time, it also has what we call variables. It has variables such as maybe x, y, z, like that, and then numbers like 1, 2, -5, like that, etc. And then it also has what we call no equality sign. So there is no there's no equality sign. There's no equality sign in there. There's no equal to sign in there. So any expression you see without an equal to sign in there is, so an example is maybe x minus y. It's an algebraic expression. Or let's say we have minus 5 plus z minus 2y. This is an algebraic expression because there's no equal to sign in there. So that makes it what? An algebraic expression. That makes it an algebraic expression. Now we can give an example. Maybe we have 7 x squared minus 3x minus y minus 2z plus 4p minus 5x. It's a very typical case that we can find an algebraic expression. Now there are certain rules. There are certain rules involved when you want to add or subtract. So when we want to add or subtract an algebraic expression, we first of all make sure that the variables are the same. The variables have to be the same. So in this case, if you look at this 3x here and the 5x here, they can come together because of the variable. This variable is the same as that variable. This x squared is different. This one here, this x squared here is different. It's different. So x squared is not the same as x. The variables are different. So we bring the variables that are together. People use the term, we bring apples together and we bring oranges together. So we can say the x squared could be apples and then the x could be oranges, all right? Something like that. So make sure the oranges are coming together. Maybe the z could be maybe a cucumber. All right, so we cannot be able to add them to the y could be something else, or the p could also be something else. So for us to add or subtract, we want to make sure that the variables are the same. The variables in question that we want to deal with, they are actually the same. So if we have, let's say, minus 3x and a minus 5x, if we have these two, the minus 5x, we can be able to work with it. Because this sign here, the x here is the same as this x here. So what we can do is that we take negative 3 and negative 5. Why negative 3? This is it, negative 3 right here and negative 5 right here. What do we get? We are owing. This means we owe $3 and we also owe another what? $5, and that means we owe a total of $8. So that's negative 8. So that's going to give us negative 8. That's going to give us the negative 3x. Let me write it again. The negative 3x minus 5x is going to give us what? A negative 8. It's going to give us a negative 8. And then we're going to just attach the x to it. We're not going to add the x. We just attach it to it. That's it. And then we are done. So we want to add and subtract. We want to make sure. So if let's say we take something like, let me wipe this one off quickly. Let's say we have something like 7x squared plus 4p. You can tell by hindsight that this x squared here is different from the p. So we cannot do anything. We can't do nothing. We can't do anything about it. We can't do anything about this. We leave it as it is. But however, let's move on to maybe we want to multiply. Let's say we're thinking of doing a multiplication of an algebraic expression. For example, let's say that we have, let's say, 7x squared multiplying 4p. You see that this variable here is different. It's different from this variable here, but it doesn't matter. Whenever we are dealing with multiplication and division, we want to multiply. Or divide. It doesn't matter. We want to multiply or divide. It doesn't matter. So what it means is that the 7 will multiply the 4. This 7 here will multiply the 4, and it will give us. We're going to get 28. And then also we're also going to have the x squared multiplying the p, and we bring all of them together. We get x squared p, or you can also write it as p x squared. However you arrange it doesn't matter, because multiplication, it doesn't matter. The arrangement is the same thing. All right. So based on that, if we are rewriting our problem, it was 7x squared times 4p, right? So we are basically going to get this times this, which gives us 28, and then the x squared p will come together to p x squared, like this, and then we would have solved our algebraic expression. So those are the things we're going to be seeing when we go into equations. So that's why this is more fundamental, so that when you see numbers and variables or alphabets together, you and I don't get scared. So in this video, we're going to learn and find out that equations. There's a reason why equations are easy, and it's not a scary thing at all. So as we move on, we are going to what we call the main meat proper. We're going to start with equations. but we just did the algebraic expression as a foundation for us to be able to go in equation. Because in equations, we're going to see numbers and we're going to see variables also at the same time. Now, in this video, we're going in this equations, we are going to find what we call the different types. We're going to look at the different types of equations, but different types of equations. But before we do that, let's try and see if we can give a definition of what equations are. So by definition, we say equations are, they are mathematical expressions. They are mathematical expressions or algebraic expressions, mathematical expressions, right? Or we can say that they are what? They are also algebraic, maybe algebraic expressions. And what happens? But this time around, they contain the equal to sign. They contain the equal to sign. There's the equal to sign inside there. So anytime you see an equality sign in an expression, then you are dealing with an equation. So with that should be the mindset. But without an equality sign, then we are looking at without an equality sign, we are looking at algebraic expression or just a mathematical expression. So now let's look at the different types. We're going to look at the different types. We're going to look at types of equations. And by that, we're going to have the first group. The first group of equations is what we call the linear. We're going to look at the linear equation. We're going to look at the linear equation is the first group, and then the second group is what we call the polynomial group. And in under the polynomial group, we have the first group. We have the quadratic group. So a quadratic is a polynomial, and then the next one we can say is the cubic equation group, and then we can also have the aquatic group, and then we can do to the nth degree type of equations. So these are the different types of equations that are out there. So we are going to go straight into linear equations. We're going to go into linear equations. Our focus now is going to be linear equations, and linear equations was propounded by Sir William Rowan Hamilton. It was propounded by Sir William Rowan Hamilton, and he did. He's the one who founded this, and we've already looked at the definition. We said linear equation. They are of the form, no equation. We previously looked at the definition of equation, but with linear equations, they are of the form. We can define linear equations as equations, as equations of the form. They are of the form. Usually, they are of the form y is equal to a plus bx. Some textbooks will say, or they will say maybe y is equal to mx plus c. You will see these two different things. And now, don't let us scare you. What this means is that this y here is usually known as a dependent variable. It is known as a dependent variable. Why is it a dependent variable? Because it wants, before we can be able to get an outcome of this particular variable, it will rely on this x. This x is what will generate it. So the x is the independent variable. That means it generates. It's the one that generates. Is a generator. It generates generator of y. It generates y, or basically it is the cause. We can use the word the cause. Is the cause, and then there's an effect here. There's an effect. Whenever x causes something, there's an effect on y. That's why y depends on x. So y there is a dependent variable. Y is a dependent variable, or the explained variable, or maybe the explained variable, and then the x there is our independent variable. Now, what about the y? What about the b? Sorry, what about this b here? This b here is known as the gradient. The b there is known as a gradient. First, it's known as a gradient, or what we call the slope. So, depending on the country you find yourself, either the gradient or the slope. And this b there can also be known as, it can also be called the coefficient of x. It's also known as the coefficient, is the coefficient of x, is the coefficient of x, and we can be able to define what that is. So we'll get into that in a little bit. But what about the a? The a there is a constant coefficient. Is a constant coefficient. A constant coefficient. Yes, coefficient, constant coefficient, or the y-intercept. When basically where the line cuts the y-axis, so it's a constant coefficient. It's a constant, and it's the same for this as well. This y here is the same thing. It's a dependent variable. And then this x is the cause variable. It causes y to behave, right? And then we also have our m is the slope or the gradient. Is the slope or the gradient, or what we call the coefficient, or the coefficient. So it's the same thing when you see in a different text. It's the same, the coefficient of x, the coefficient. And then we also have our c here, just as known as the constant. Is also known as the what? The constant coefficient. So now now we can be able to, based on it, be able to compute what our gradient and slope is. So we are now going into the determination of a slope. So we are going to look at slope or a gradient. How do we arrive at that? So let's say that we are still sticking by the first equation, y is equal to a plus bx, right? Or we are saying that it could be, or we are saying that it could be y is equal to mx plus c, right? So we are saying that the b, which is the same as the m, is what we call the slope, or what we call the gradient. And we are saying that gradient is a formula. We're saying as a formula, it means a change in y or a change in x, or an increase in y over an increase in x. And basically that is the same as saying y2 minus y1 divided by x2 minus x1. So that, there you have it. That's the slope. That's the formula. A change in, and we're going to look at it graphically. To look at that graphically, let's imagine we have this, and we have something, a line. This is a straight line. So this is a line, and we are saying that we are calling this line y is equal to a plus bx, or y is equal to mx plus c. We are calling that, this is the line. Now imagine we have a point. Let's just for a second create a point. So let's say this is our first point, and this is the y-axis, don't forget, and this is the x-axis. All right, y-axis and x-axis. So if this is the point, let's imagine that this point is, let's say, 3. The y value here is 3, and then there's also an x. There's also an x value here, maybe 1 or something like that. Let's say it's 1. Okay, so let me change this again. Let me make this one 2, and make this one 1. And then there's also another point we're going to pick. Maybe another point is here. We are saying that point here is 1, and then this point here is rather 2, for example. Okay, it's rather 2, for example. So what it means is that if we're going to put it in our formula, the b or the m is going to be y2, right, minus y1 over x2 minus x1. Now here, what is this point here? Remember, this point is the x. We always choose the x first. The x value is this one. So 2 will be here, comma what? The y. So it's always the x value first, which is 2, comma what? The y, which is 1. And then here is also what? The x value first, which is 1. So put 1 here, x first, and then the y later, which is 2. So now we are being asked to compute a b, which is a gradient. What does a gradient mean? It means how sharp, how steep is this line? How is this line changing in terms of slope? How is it changing? How steep it is? Okay, how steep is the line? That's what we want to calculate. We want to count how steep the line is. And to do that, we are saying y2. So we can decide. It's up to us. We can decide that this is our x1 and this is y1. Or we can decide that this is our x1 or y1. And we're going to get the same result. It doesn't matter whichever one we pick and choose. If we pick any other one, it will be fine. Okay. So let's say this is our x2, and then this is our y, and then this is our y2. Okay, so now what it means that the y2 is this one, the one here. So we're going to put it, we're going to plug it into the formula 1. This is y2, which is 1 here. This is y2, 1. Minus, don't forget the minus. The minus comes before the y1. What is the y1 there? The y1 is 2. So we're going to put 2 here. We divide it by x2. Where's x2? Our x2 is this one here, is a 2. Minus, we bring the minus there. And x1, where's our x1? Our x1 is 1. Put it there, and then we're going to get the top. The numerator is going to be negative 1, and the denominator is also going to be 1. And then basically, our b, which is equal to the same as the m, is the same as negative 1. So our slope or gradient, is negative 1. Is negative 1. So this is how slope and gradients are computed. This is how slope or gradients are computed. But we want to see, we want to make a little quick comparison between slopes and slopes or gradients, right? Versus differentiation. Now remember that the slopes and gradient that we've talked about, the formula. Remember that this formula that we generated, this y, this y is this. Give me a second. The formula we generated for b, right? We generated b formula, which we said is the same as the m, which we called it a slope. We said the formula is what? Increase. Remember, increase in x. Increase in y, right? Increase in y divided by an increase in x. You remember that, right? So this particular formula applies strictly. It applies strictly, which is equal to change in y or change in x, which is equal to y2 minus y1 divided by x2 minus x1. We are saying that it applies to linear equations. Linear, whenever you are dealing with linear equations, you're talking about straight lines. It only applies to straight lines. But in real life, everything is not straight. we might have curves. We might have a curve like this, maybe a curve like this, and we will want to compute. Remember, the points will be different. The points are not on a straight line. Look at here. They are not on straight lines. They are on a curve. The points are on a curve, not a straight line. So if we want to compute a slope or gradient of this curve, we can't use this. It cannot be equal to this y2 minus y1 over x2. Man, it can't be that. What are we going to do? We have to use differentiation. So that's where differentiation. I'm trying to give us a relationship between differentiation and slopes. They are the same, but just that we apply the rules of differentiation to determine. So differentiation. So let me write it here. Differentiation helps us to determine. It helps us to determine the slopes of nonlinear equations. Of linear equations. The equation is not linear. Differentiation can be able to help us be able to achieve the determination of the slope. So slope of a nonlinear equation can be determined using differentiation techniques. So differentiation helps us to be able to achieve that. And to do that, remember that we said that differentiation is what changes. So basically, it involves changes, small changes in the variable, small changes in y. Small changes in y. We'll say smaller changes in y over smaller changes in x, and as it approaches 0, we end up getting dy, what we call dy dx, So instead of using our change in y, this formula here, we are saying that it becomes dy dx. So that's a relationship between slopes and differentiation. So slopes and differentiation are kind of the same, because slopes are trying to find how steep something is, right? Differentiation is also trying to achieve that. But when it comes to slopes for linear equations, we use this formula. But when it comes to slopes for differentiation, we use this term, dy dx, and then we apply the rules that are there in terms of differentiation. I hope that clarifies that. Now, remember, we're still on linear equations, and we've looked at the definition. We said it's an expression that involves an equal to sign. And we've also talked about we've looked at the slopes, and we've looked at the different variables in the form. We said that a linear equation is of the form y is equal to a plus bx, and we said what we determine what a y is, we determine what a y a is, we determine what a b is, and we determine what the x is. So remember that we've been able to achieve that. So moving forward, we're going to look at how to determine. How do you think we can determine the equation of a line. How are we going to be able to determine the equation of a line? So let's look at equation, how to determine the equation of a line. The equation of a line. How do we do that? The equation of a line. How are we going to be able to achieve that? Remember that the target is to be able to give us an equation in the form y is equal to a plus bx, or it should be in the form y is equal to mx plus c. This is the goal. This is the whole goal. So let's keep that. Let's have that in mind. That's our goal. We want to be able to achieve that. Okay. So now the first thing we would need to do is to compute what we call we need to have what we call an x-intercept. The first thing is to look for the x-intercept, which means when y is 0. And then the next thing is to look for what we call the y-intercept. And to find the y-intercept, it is when x is 0. It is when x is 0. And then you use a and b. We'll use a and b. Sorry. We'll use a and b and a point, 1 point, to 1 point, to determine the value of the constant, the value of b, like the value of a or c, the value of a, the value of a or c, the value of a or c here, this one. So that'll be the test step. And then finally we'll plug it in. Finally we plug, and then c is to plug in. Okay, so let's imagine that we have, let's imagine for a second that we have maybe a straight line, right? We have a straight line like this, maybe like this or so, right? Let me do it well. Or let's say that we are not given the diagram, but we are told that the points are, we have a -2, a -1, and then we also have maybe this point A, and then we have a point B. We have a point B, which also talks about a negative, maybe a 4. Let's say a 4, and maybe a negative 4, maybe something like this. So we said that the first thing, remember that we're saying that the first thing is to find when x is what, when y is 0, the x-intercept. That means when y is 0. For the x-intercept when y is 0, the first thing we've got to do is to find a gradient. I'm sorry about that. The first thing we got to do is to look for the gradient. So let me put it right here. Let's say the first thing is to calculate the slope or the gradient. Okay, that'll be the first thing. So the first thing is to compute the what? We are going to look for the gradient or the slope. And remember that we said that is what? The b or the m, right? And we are saying it's the same as change in y over change in x, which is y2 minus y1 over x2 minus x1. So we can be able to plug in, right? We can be able to plug in the values, and then what are we going to get? If we say that this is our x1, and this is our y1, and this is our x2, and this is our y2, then our y2 in the formula, that's y2 minus y1 over x2 minus x1. Our y2 in the formula is -4. Now there's a minus that we need to show, a minus, a y1, and y1 is -1. Don't forget, the y1 is -1, but this negative sign comes before that -1. Divided by x2. What's our x2? Our x2 is 4. And then there's also a minus in the formula, and then the x1 will come in. The x1 there is -2. So please don't forget that. It's very important. Now the next thing we're going to have is -4. Now this negative and negative, because of the parentheses, is like multiplication. So it's going to be times plus 1. Sorry, I said times plus 1. It's going to be plus 1. It's going to be plus 1 because negative multiplied by a -1 will give us a positive 1 divided by a 4 plus 2. And then we're going to get -3 at the top divided by 6. Why are we getting -3 at the top? -3 at the top? Because -4 is what you owe. And then the plus 1 is what you have, wallet. It's in your wallet. So even if you pay 1 to what you owe, you still owe $3, which is -3. So that's how come we are getting the -3 from the top there. And then we can simplify it. And we get, there's a common factor. The common factor is what? 2. So 3 goes here 1, it goes here 2, and we get -1/2. So our B or M is 2. Our b or m is this is negative 1 over 2. Negative 1 over 2. It's negative 1 over 2. It's negative 1 over 2. So don't forget that. It's negative 1 over 2. Now we're going to the step, which says step A. Step A says x-intercept. Okay. So we're going to have so far, if we look at our equation, we have y. Y is equal to a plus bx, right? So far, we have our equation looks like this: y is equal to a minus half, right? X. We have this. So this is what we have. So we are saying that our first step, our a, this one, when y is 0, we are saying that we are going to look for this a, right? And to look for this a, we pick one point. This point. We are here. We pick one point. And the point we pick could be any of this. It could be this or that. So if we pick, let's say, point A, point B, which is 4 and negative 4, if we pick any of them, right, this 4 is our x and this is our y. So we're going to plug our y is negative 4, which is equal to a, that we don't know, minus half, and then our x is also 4, right? So we're going to have negative 4, this negative 4 is equal to a minus half to 4. And we know there's a common factor. 2 go here, 1 goes here, 2. And we're going to have negative 4 is equal to a minus 2. Can you see that? Minus 2 over 1 is 2. And now we can solve for a, right? Because a can stand here alone, and then negative 2 can go to the other side. So what it means, we're going to have negative 4 plus 2 is equal to a. And then we're going to have, this is what we owe. We have what we owe, which is 4. We owe 4, and we are paying 2. So we still owe 2. So it's going to be a is going to be negative 2. All right. So we can boldly say that, our linear equation is basically y is equal to what? The a there is negative 2. This a is what we look for here. So it's negative 2, and then we are going to have what? The slope, which is negative half. This b here. This b here is negative half, and then we attach the x. So basically, this is our equation, but we can still simplify it. We can simplify it by multiplying each side by 2, and then we can be able to do this. But if you leave it as this, it's also okay. But sometimes you're working a problem and it's left in the most simplest form, and then you multiply both sides by 2. You're going to get 2y. If you multiply both sides by 2, you get 2y is equal to negative 4 minus x, and then that'll be the equation there, right there. All right. I hope this helps for equation of a line, how to be able to estimate the equation of a line. And then now we move on into polynomials. We've now looked at a linear equation. What a linear equation? Linear equation is an equation that was invented by Sir William Rowan Hamilton, and we said it's of the form y is equal to a plus bx, or y is equal to mx plus c. The b or the m are known as the slopes of the gradient, and we said that b in this form is always relates to the equation of a line, a straight line. But when we want to do with curves, then we are going to apply the differentiation techniques to be able to estimate the slope of a curve or any other nonlinear kind of equation. We've also looked at how to be able to determine the equation of a line if you are given 2 points. If you are given 2 points, the first thing is to use the 2 points to determine the slope. We use the 2 points to determine the slope. And once we were able to get a slope, we put the slope back into the equation, and then we put one of the point into the what we have, and then we are able to generate the equation of the line. Now moving forward, we are going to look at polynomials. And polynomials are different from linear. They are different. They are not the same. They are different from linear equations. All right. So we know that if we do a table, let me do a quick table. So let's say linear equation is here. All right. we can see that linear equations are what? Straight lines. They are straight lines. And then they are of the form, linear equations are straight lines, and they are of the form y is equal to a plus bx, or y is equal to mx plus c, right? But we are saying that aside that, we have what we call polynomials. And for polynomials, you have what we call anything that is a polynomial is anything that is has a bigger degree than this x. Can you see this x here? To the power 1. This one is to the power 1. So the moment you have a degree, maybe x squared, x to the power 3, x to the power 4, x to the power 5, then they are no longer linear equations, but they are what? Linear expressions or linear equations. So this is a polynomial. This is also a polynomial. This one is also a polynomial. That's also a polynomial, but they have names. So this polynomial here is known as what? A quadratic. It's known as a quadratic because the degree is 2. And this one here is a cubic because the degree is 3. And then there's a quadratic because the degree is 4. In that order. The degree here is 4 in that order. So we've looked at linear equations that they are straight lines, but we're saying that with polynomials, they are not straight lines. They are not straight lines. They can be curves. They can be curves. They are not straight lines. They can be curves, or they can be any other non-linear expression or form. All right, and it can be y is equal to ax squared plus bx plus c, or it could be y is equal to ax cubed plus bx squared plus cx plus d. Yeah, in that order, like that. So that's what differentiates polynomial. Remember, we categorize the equations under linear equations or polynomials, and now we're going to go into, we've determined what a polynomial looks like. It's of the degree more than 1. The x here is of degree more than 1. Okay, so if you have y is equal to mx squared plus c, this is no longer, it's not a straight line. Why? Why is not a straight line? Because of this 2 here. So the moment this degree is 1, let's say y is equal to x plus 5, then this is a linear equation. It's linear because the degree is 1. And then the whatever, the m here is 1, right? It's a linear equation. So now we've looked at what a polynomial is, how a polynomial is different from a linear equation, and we are going to move on to now go into the nitty-gritty by looking at a quadratic, the first type of polynomial. So the types of polynomials. Remember, we mentioned that it could be quadratic, it could be quadratic, it could be a quadratic, it could be a cubic function. It could be cubic, or it could be what? Aquatic. Or it could be what? Nth degree, and more, right? But we're going to focus solely on what? Quadratic equations. Yeah, quadratic equations. That's what we're going to focus on. Now, they are of the form. How do you write a quadratic equation? They are of the form y is equal to ax squared plus bx plus c. Or sometimes you can see it being written this way: ax squared plus bx plus c is equal to 0. So it's the same thing. Remember, there's an equal to sign here, so that makes it an equation. There's also an equal to sign, that makes it an equation. But we're going to see more of this. Sometimes you might also see it in this form. Maybe f of x is equal to x squared plus bx minus c. It's still a quadratic equation. It doesn't matter whether there's a y here or an f of x here. The moment this thing is a squared in it, and that's the highest degree in it, then that makes it a quadratic equation. So we're going to look at quadratic equations, and there are 3 methods in solving quadratic. There are 3 methods. So there are three methods for solving. 3 methods for solving them. Now, the first one is known as the factorization method. It's known as the factorization method. The next one is known as the quadratic formula. And then the last method is known as the completing of squares. Completing of squares method. Right. So there are three methods. So we are going to start with the quadratic equation. Quadratic equation, but focusing on the what? We're focusing on the factorization method. Sorry, we're going to focus on the factorization method. We're going to focus on the factorization method. What does it say? What does it say? We're going to look at factorization in two ways. We're going to look at it in two ways. The first way, is to imagine that we have, let's say we have x squared. First thing is to always rewrite the quadratic expression. Always write this ax squared plus bx. Always write it down before you solve a problem. This one, write it down. Very important. Now, the next thing we do is we are going to take an example. The first way of doing a factorization method, the first way is, let's imagine that you see this. Let's say you have x squared plus 6x plus 9, and write them under each of them. You can see that I've written this one under this one also comes under it, and this also, in that way is equal to 0, right? Now, can you see the values? You can tell that a here is 1. You can see that. And then you can also see that the b here is the whole of the 6, which is plus 6, right? Which is basically 6. And then you can also see that the c value there is plus 9, which is 9. Can you see that? It's very important. Now, anytime, the first method under the factorization method is if anytime a is equal to 1. Anytime a is equal to 1. Anytime we see this, anytime a is equal to 1. Like in this question, a is equal to 1. This is what we are going to do. We will look for the factors. We first look for the factors of c. First look for the factors of c, and in this case, the factors of c is plus 9, which is 9, right? And these factors that we are going to look for, the factors that we are going to look for, when we multiply these factors, so we are saying that we're going to look for factors of c. So let me rewrite that again. So it's going to be, we're going to look for factors of 9, and those factors, when you're able to multiply those factors, you are going to get what? Plus 9. Don't forget that. When you multiply that you get the c, which is equal to plus 9. But when you add them, those factors that you look for of 9, the factors of 9, anytime the a is 1, don't forget, anytime the a is 1, you look for the factors of the c, and in this case the c is 9. And when you multiply, you need to get that plus 9. When you multiply the factors of 9, they should give you plus 9. But when you add those factors that you have looked for, you should be able to get the plus b. The plus b. And that plus b there is plus 6. Can you see that? Which is actually 6. And this was actually 9. Okay. So if we look at the factors of, what are the factors of plus 9 or 9? What are the factors of that? The factors of 9 could be 9 times 1, or it could be what? 3 times 3. Can you see that? If we pick this 9 times 1, when we multiply them, yes, when we multiply, we are getting what? The plus 9. But when we add, are we going to get the plus 6? This the plus 6. When we add, we get plus 10. So this cannot work. This is a no. We cannot use this. However, when we take the 3 times 3, when we multiply this 3 times 3, when we multiply them together, we're going to get plus 9. But when we add them, do we get a plus 6? Yes. When we get plus 6, well, 3 plus 3 will give us the plus 6. So we can use this. This is doable. We can use this. We can use it. It works. It works. So the factors there. So therefore, we can say that the factors of 9 to use are what? 3 and 3, which is plus 3 and plus 3, like that. The moment we know this, all we need to do is just write this down. Write your x and then the factor. This factor is plus 3. If it's negative 3, it will be negative 3. Then write another x in the next one, plus 3. So if the factors were, let's say, negative, let me just say, I'm just saying, let's say the factors were, let me change color. Let's say the factors are negative half and 1. What we're going to get is, it's going to be x minus half, and then you're also going to get x plus 1, because these are the factors. This one, negative half and 1. and then you equate it to 0. And once you equate it to 0, you can solve it, because you have x minus half is equal to 0. You also have x plus 1 is equal to 0. Now this is going to give you x is equal to 0 plus half. This is also going to give you x is equal to 0 minus 1. And x gives you negative 1. And this gives you x is equal to half. In that order. So here, we're going to equate to 0. We get x plus 3 is equal to 0. X plus 3 is also equal to 0. They are the same. So x equal to 0 minus 3. X is equal to 0 minus 3. In that order. So that's the first way we are going to be able to do a factorization. The moment this a is 1, it's easy. You just focus on the c, the factors of the c, and then we don't have to solve anything. We just pick the x and the factor. X and the factor. We group them together. So let me give you an example again. Let's say you have x squared minus 3x minus, let's say, 3. Okay, minus 3x let's say together minus 3x is minus 2 minus 1, so plus 2. Let's say this is it, because this side here, because we're saying that because here is 1, you can see it's 1, we just focus on the plus 2, so that we are looking for factors of plus 2, that when we multiply, we get a plus 2, but when we add, we are going to get minus 3. Don't forget we're going to get minus 3. So the plus 2 there, what are we going to get for the plus 2? The factors for the plus 2 is going to be what? Negative 2. We said negative 2, negative 1. So when we multiply, we're going to get plus 2. So this is going to give us negative 2, the factors, negative 2 and negative 1. When we multiply them, we get plus 2. But when we add negative 2 and negative 1, we get negative 3. So we can see that the factors of plus 2 is actually negative 2 and negative 1. When we multiply them, we get plus 2. But when we add, we get negative 3. And it satisfies what we're looking for. So once we've looked for the factor, we're saying that just take x. Just take the x and minus 2. This is the first one, minus 2. And another x, and then minus 1. This is minus 1. That's it. It's equal to 0. And then you're going to have x minus 2 is equal to 0. And you're also going to get x minus 1 is equal to 0. So here it gives us x is equal to 0 plus 2. Why plus 2? Because this 2 is going to cross this equal to sign. And then it's going to give us x is equal to 0. And it's also going to cross. So the sign here will change to be plus 1. You get x is equal to 1. And you get x is equal to 2. So I hope the first way works. But there are times, that things will change. For example, we are still on the factorization. Sorry, we are still on the factorization method. And under the factorization method, we are going to look at the second way. We looked at the first way, and now we are going to look at the second way under the factorization. So imagine that we have 2x squared minus 4x plus 2 is equal to 0. All right. Now the first thing is you can see that this thing is not 1, and because of that, we're going to multiply the a. Remember, we said we should always write even the expression down. Ax squared plus bx plus c is equal to 0. So what is going to happen is that the a will multiply the a by the c. So what will you get? In this case, our a is 2, right? Can you see that? Our a, let me write it here. Our a here is 2. Our b here is negative 4. Can you see that? It's minus 4. And then our c is plus 2. So what we're going to do is to multiply the a by the c. A by the c. And what's the a? The a there is what? Plus 2. Multiplied by what? The c, which is plus 2. And that gives us plus 4. Because we are multiplying. So now it is this plus 4 that we're going to look for. Look for factors. Look for factors. So we're going to look for factors of plus 4. So we're going to look for factors of plus 4 such that when we multiply, don't forget, when we multiply this factors that we are looking for, which is plus 4. When we multiply the factors to get plus 4, we are going to get plus 4. However, when we add those factors that gives us plus 4, it should rather give us what? The minus 4. It should give us the minus 4. Don't forget that. It should give us the minus 4. So we're going to go into search. We're going to go into search. What are the factors of plus 4? Plus 4 could be, the factors of plus 4 could be plus 4 factors. It could be negative 4 times negative 1, which will give us plus 4. But when we add, we're going to get negative 5. Can you see that? Because negative 4 minus 1 is giving me negative 5. And that's not what we have there. What about What about negative 2 and negative 2? Can you see that? Other factors of plus 4, because we know that plus 4 factors is we can get negative 2 and negative 2, or 2 plus 2, 2 times 2. If we get 2 times 2, that gives us plus 4. But when we add 2 plus 2, we are going to get plus 4. And this plus 4 is not what we have here. So if it's not, it will not work. So two positive numbers, the plus 2 or plus 2 will not work. It will not work. But we can use what? Negative 2 and negative 2. If we multiply negative 2 and negative 2, we get plus 4. If we add negative 2 and negative 2 together, we're getting negative 4. We are owing two different debts. So it gives us a negative 4. So we are getting that. I hope that clarifies. So basically, we are saying that the two factors that when we multiply, we get plus 4 is what? Negative 2 times negative 2 gives us plus 4. And then when we add negative 2 plus negative 2, we're going to get negative 4. So basically our factor, therefore, our factors are negative 2 and negative 2. Now we are going to solve. So remember that the problem was 2x squared minus 4x plus 2. Don't forget that, which was 0. All right. So what we're going to do is to apply what we've gotten. We're going to start by writing 2x squared. And what was the factor? The first factor is this minus 2. So minus 2x will come. And the second one is what? Another minus 2x. So minus 2x. And then we're going to add the plus 2. Can you see that? We're going to add, because this is what we did. We've broken this one down. So the two factors that we had is this minus 4. And we bring this 2 here. Don't write a 4. Whatever I see here, so we're going to write here. It's equal to 0. We are not going to use the a times the c. The a times the c. This one. We're not going to use that to write down one here and change it to 4. It's going to be plus 2 here. All right. It's the factors that is going to give us the minus b. The negative 2, negative 2. Are you okay? Now we're going to group them together. And to do that, we're going to have 2x squared minus 2x together. And then don't forget, we're going to bring this minus. The moment we bring this minus, we bring a parenthesis out. We bring a parenthesis, and then 2x will go inside. And then we're going to get negative. Why negative? Because when negative multiplies a negative, we get a positive here. So watch out for that. We are putting them in parentheses. And this negative multiplying this 2 will give us this negative 2. So we are good. So always check. You can always check that when you put them in parentheses and you are trying to remove the parentheses, will you get back what was originally here? We should always look out for that. Now, what are the common factors? We can see that if you look at this whole thing, the common factor there is 2 and x. So here is going to give us x minus 1, because this 2 is here, there's a 2 here, it comes out. And then we look at x squared and x. This common factor is x. So we bring the x out and we get x minus 1 inside the parentheses. Now, another minus. If we look at this 2 again, what is common is 2. So we'll have inside to be x minus 1 is equal to 0. Now, because this and this are the same, we'll put them together. So 2x minus this 2 will come together, and then the factor that is the same goes to another parenthesis equal to 0. Now we're going to have what we look for. We're going to have the 2x minus 2 in one parenthesis. Then x minus 1 is equal to 0 in another parenthesis. We're going to have 2x minus 2 is equal to 0. Or x minus 1 is equal to 0. Now we're going to look for x. So 2x will be here. The 0 stands here, and then plus 2. Why plus 2? Because this has to come here. And then this also becomes x is equal to 0. This also comes here, and the sign changes to plus 1. We're going to get 2x is equal to 2. Or we're going to get x is equal to 1. And basically, we're going to get x is equal to 1 because we divided by 2, divided by 2. And then x is also equal to 1. I hope the first method, the factorization method, is clear. It's clear for all of us. Whether it is the one way where you're having the a to be equal to 1, or it's not equal to 1, and what you anticipate to do, so that it can work very fast. So this video is telling us why equations are easy. If you haven't yet subscribed to our channel, please do us a favor so we can grow this channel as a family together, so that we can be able to help as many people around the world as possible. Thank you so much. If you're already a subscriber, thank you for supporting this channel. We're continuing. We're going into the quadratic equations, the second method. We're looking at quadratic equation, quadratic equation, and we are looking at the second method. What's the second method? We said the second method is known as the quadratic formula. If you remember, we said it's a quadratic formula. Is the quadratic formula. In certain countries, they call it the almighty formula because it scares a lot of people to death. But we are here, and we're saying that math equations are easy. Now, We always say that we should write down the expression ax squared plus bx plus c is equal to 0. Write it down. Always. Always. And then once we write it down, imagine we are given a problem. Maybe we are given a particular problem. Maybe for example, we are given 2x squared. Maybe we are given 2x squared. And we are also given minus 4x, like what we did earlier. And then plus 2 is equal to 0. So now, because we have this, the first thing we're going to do is say that the a, we can see, that a here is 2. We can also see that our b, our plus b is equal to negative 4. Can you see that? And then our plus c is equal to 2. So basically, we can say a is 2, b is negative 4, c is 2. And now we're going to put out the formula. The formula was usually generated by the third method. So this formula I'm going to write, which is x is equal to minus b plus or minus. Some of you at some stage, you need to memorize this. Everybody might memorize this. So b minus b plus or minus the square root of b squared minus 4ac. And then we divide everything by, let me delete that again. I think it didn't come out. It didn't come out well. So we divide everything by 2a. We divide everything by 2a. We divide everything by 2a. So we're going to plug in the values. So x is going to be equal to the minus b. There's a minus first. But what is our b? Our b is negative 4. So put negative 4 in there. Don't forget, this came before the b. So minus should come, and the b, you put it in there. Plus or minus square root of b. What is the b there? The b is negative 4. And then we square it. Minus 4. And what is our a? Our a is 2. Our a there is 2. And what is our c? Our c is also 2. And then we divide everything. Everything will be divided by 2a. What is 2a? A there is also 2. If you want to do it this way, you have to do this parenthesis to show that this division sign applies to all that you have written on top. All right, it's very important. Now we're going to simplify. We have our x. We have our x to be equal to, this is giving us 4 plus or minus square root of 16. This gives us 16 minus, this gives us another 16, right? Well, this times this 8 times 2, 16. And then we divide everything by 4. Can you see this 4? And once we have that, we can be able to simplify things, right? It's going to be, we're going to have 4, this 4 here comes, plus or minus this square root of 0. Can you see that square root of 0? 16 minus 6 is square root of 0. And then it's going to be divided by 4. Now the top part, we're getting x is equal to, it's going to be 4 plus or minus 0. Can you see that? 4 plus or minus, the square root of 0 is 0. And then we divide that by 4. And we're going to get x is going to be equal to 4, right? 4 divided by 4. We're going to get 4 divided by 4. And the x is going to be equal to 1. So this is how the quadratic formula works. It's basically knowing this, writing this formula down is the whole thing, and then plugging in. You first have to know this formula so that you can now put in the values of the variables. How do you know the variables? You need to write this ax squared. Always write this ax squared. Always write it down. It's very important. Ax squared plus bx plus c is equal to 0. That needs to be written down first. And then the problem that you are being presented, if it is, let's say 3x squared minus 6x minus 4 is equal to 0, then we can be able to estimate what this our a is, right? We can be able to tell that the a here, a is 3. We can also be able to see that our b here is negative 6. We can also be able to see that the c is negative 4. Then now you can be able to chuck in the values. You can put in the values. You write the formula down, minus b plus or minus square root of b squared minus 4ac all over 2, and then you plug in the values that you have put in here. You substitute, or we call it, you substitute the values or the variables that you have, and you put it in there, and then I think you're good to go. So this brings us to an end to the quadratic equation, the second method, and then we are going to look at the third method. The third method, which is completing of squares. So we're going to look at completing of squares. Completing of squares. This is usually used when you can't find the factors of a times c. It's difficult to find the factors of a and c. Then you have to rely on completing of squares. Yes, that's the reason why we use that. So let's imagine that we have this question. We have 2a squared minus 4a minus 5 is equal to 0. You see this side, if we try to even use the second method or the first method, this thing is not equal to 1. So what do? We normally multiply a and c, right? So it's 2 times our negative 5. This is c. Negative 5, we get negative 10, right? And we look for the factors of what? Negative 10, right? Then when we multiply, we'll get what? Negative 10. But when we add, we're going to get what? negative 4. When we add, we're going to get negative 4. Now, what are the factors of 10? It's going to be what? 5 times 2, right? Either one of them is the negative. So if we add negative 5 plus 2, we get negative 3, which is not the negative 4 we are looking for. And here gives you negative 10 though. If we do 5 times negative 2 and we add to negative 2, we are getting here to be positive 3, and the top is negative 10. It still doesn't help us. It doesn't help us. So you can tell that this one, the first method, is not going to help us. And if the first method cannot help us, then that means that the second method cannot be able to help us. So we only use the third method of solving quadratic equations when the first and the second method fails us. We call it the completion of squares method. So this is the third method. If it fails us, the first and second fails us, then we can use this. Now, what do? We say that the first thing we do is to divide. Okay, we divide. We want to make is to make coefficient, right? The coefficient of a squared. Coefficient of a squared. What's the coefficient of a squared? Is 2. This is a squared. So the coefficient of it is 2. We want to make the coefficient of a squared to be equal to 1. We want to make it to be equal to 1. And to do that, to do this, we have to divide through by 2 so that we can remove the 2 there. So doing that, we're going to have 2a squared divided by 2 minus 4a divided by 2 minus 5 divided by 2. If the coefficient is negative 2, you divide by negative 2. We're going to have 0 divided by 2. And then when we do that, we end up getting what? 2a squared over 2 minus 4a over 2 minus 5 over 2 is equal to 0 over 2. And then we cancel, right? This one cancels out. This goes here 2. And then we have what? We end up getting, we are going to get a squared minus 2a. Can you see that? Minus 5 over 2, which is equal to what? Is equal to what? Is equal to 0. Is equal to 0. Now, we are going to take, what we're going to do next is to take half. We're going to take half of term A. Half of term A. What is the half of term A? What's the term of term A? So we are going to take, we're saying that we should take half of term A. Okay? We take half of the term A. Or we are taking half of coefficient. The coefficient of A. All right? We're going to take half of that. And then to do that, we're saying that what are we going to get? The coefficient of A is what? The coefficient of A is negative 4. Can you see that? This is the coefficient of A. It's negative 4. So half of negative 4 is the same as half times negative 4, which gives us what? Negative 2. Can you see that? It gives us negative 2. It gives us negative 2. So half of the coefficient of A is giving us, is it negative 2? Okay. So the problem was having, did we do this right? No. Sorry, so now half of, so it's not going to be negative 4. It's going to be negative 2. Half of coefficient of A, it has changed because this is what we have now. This is what we have now. What we have now is here, not the question itself. So we can say that, sorry about the mess. We can say that, sorry about the mess. We can say that half of what? Negative 2 is our coefficient of A, right? Because remember that we said we have to make the coefficient of A squared. We want to make it 1. The coefficient here has to be 1. And we divided by 2. So after doing that, we have this here. So the coefficient of A is now this. It's now this guy here. That is now the negative 2 that we are having here. The negative 2. This one. This one. So half of negative 2 will give us half times negative 2, which is equal to what? Negative 1. Can you see that? God, this will cancel this and this will cancel. We're going to get 1 over 1 times negative 1, which is what? Which is actually negative 1. Now, after doing that, we will need to look for the square. We'll need to look for the square. So we'll look for the square. Okay, so let me name this one 1. And then this one is 2. So 2 we square 1. And to square 1, we are going to have what? What is our 1? The 1 there is negative 1. What we got from here? What we got from this step? This is step 1. In step 2, we are squaring 1. All right, we are squaring step 1. In step 1, we got negative 1. And to square it, it's negative 1 times negative 1, which is actually plus 1 or 1. So squaring that, we get 1. But when we took just half of the coefficient of a, we got this. So don't forget, half of coefficient of a was -1. By squaring it, we are getting 1, positive 1. I hope we're good. We're good there. So now the next thing we're going to do is, because we are here, we have -2a here. This -2a here, right? Because we're having a squared minus 2a minus 5 over 2 is equal to 0. Because we have that, what we are going to do is we're going to rearrange things. Okay, we're going to have a squared here minus 2a to stay here, so that here becomes 0, and then we move this guy here, and the sign will change to plus 5 over 2, which gives us 5 over 2. Can you see that? So we are basically having a squared minus 2a being equal to 5 over 2. Are we okay there? Okay, now that we are set about that, now remember, we already did take the half and squared it. What we're going to do, we're going to add it to both sides. So we're now going to do this step 3 here. What we did here, which was step 3, we're going to add step 2, right? We are going to add what we got in step 2, add to both sides. So where's both sides? This side is one side called the left hand side, and then this side is called the right hand side. So we're going to add what we got in step 2. So it's going to be a squared minus 2a, all right, minus 2a plus 1, all right, is equal to 5 over 2 plus 1. That's what we just did. We added it to both sides. Now we can see here that this is an expression. We can factorize this easily, right? We can factorize this. If we factorize this, or if you don't want to even factorize it, think of it as just writing a minus what we got, the coefficient, the step 1. So let's say step 4 will be to create a parenthesis for the left hand side, and have the variable plus step what? Plus step 1. Okay? The variable plus step 1. What's the variable here? In our case, the variable we're having is a. Our variable is a, and then plus step 1. What's our step 1? Our step 1 is -1. And a plus -1 is actually a minus 1. So here it's going to be a. It's going to be a minus what? 1. And we are going to get, it's going to give us 5 over 2. This is, how do you write 1 as a fraction? It's 1 over 1, right? But remember, this fraction we have is 5 over 2. So since we have plus 1, we can rewrite it as 2 over 2. So this, or we can just say plus 1 over 1, just to avoid any form of confusion. Yeah, plus 1 over 1. And then we cross multiply. This multiplies this, we get 5. This multiplies this, we get plus 2. And 2 times 1 multiplies, we get 2. We get 7 over 2. Now we're having a minus 1 squared. We're having a minus 1 squared. So we said that add the variable plus step 1 and square it. And then you square. Okay? And you square. So we're going to have a minus 1 all squared is equal to 7 over 2. And then what do? We take the square root. We square root both sides. We take the square root of both sides. So we square root both sides. We square root both sides. Square root both sides. And you're going to get square root of a minus 1 all squared is equal to 7 over 2 square root. Now, when we square root both sides, this is going to give us a minus 1 is equal to square root of 7 over 2. Now, we're looking for a. Don't forget, a is what we are looking for. So it means that our a will stand here alone, so that this one goes to the other side. So we're going to get square root of 7 over 2 plus 1. And I know you can be able to take it from there using and applying the concept of surds that we studied in our video. So you can look for the surd video, and then it will do you justice to getting a final answer. So this is how we solve completion of squares. You can pause the video, go back a little bit, look for the steps. I've left some gems in the process, so that it will make it easier and comfortable for you. It will make it easier and comfortable for you. Now we're going to continue, and as we continue and moving forward, we are going to look at what we call the polynomial. Remember that we started. I wanted to draw where we started. We started with equations, and with the equations, we started with the introduction, and we looked at algebraic expressions. We looked at algebraic expressions, and we broke down the algebraic expressions. We broke it down into, we said linear. After after the introduction, we came back to equations, and we said the equations can be broken down into linear equations, yes, and then we said that, and polynomials, and we are done with linear equations. We came out with a definition that's a mathematical expression that has an equality sign in there. It was invented by Sir Rowan Hamilton, and then we looked at the slopes or gradient of a straight line, and we also looked at how we can be able to create an equation for a straight line, and we looked at the difference between a slope for a line, a straight line, and a slope for curves or nonlinear functions or expressions or equations. All right. Now we are done with that. We looked at polynomials, and we said that polynomial is anything that is nonlinear. Anything that's nonlinear. So if the degree is 2, yes, it's 3, yes. If it's only x is linear, there's no polynomial. If x4, yes, it's a polynomial. And with that, we started off with the quadratics. We started off with quadratic equations, and we are done with the quadratic equation. We started with the quadratic, and with the quadratic, we did 3 methods. We did the factorization method, and we looked at it in 2 ways, right? One way was if a is 1, and then the second way, if a is greater than 1, right? And then the second method was using a formula. There was a formula. Remember, it says x is equal to minus b plus or minus square root of b squared minus 4ac divided by 2a. We looked at that, and we also did completing of squares. We said that if the first 2 methods fails us, we have to rely on completing of squares. So don't forget that. Now we are going into how we can be able to solve a polynomial that is not 2. Maybe a cubic function. Maybe the degree is to the power 3. How are you going to solve it? The quadratic formula will not going to help us. So what do we do? A linear function is going to help us. What are we going to do? So that's where we are now. We're going to look at factorizing, or let me say, we're going to look at how to divide polynomials, how to add them, and all those things. We're going to look at that. So let's imagine for a second that we have been given this question. They said 2x cubed plus 2x squared minus x minus 1 is equal to 0, and they're asking us to factorize. That's to factorize or solve. Factorize it or solve this problem. What do we do? You can see that the degree here is 3. The degree there is 3. It's more than 2. So what do we do? The first thing we're going to do is to do, well, the first thing we do is called to guess a factor. To guess a factor. And to guess a factor, we can assume, maybe we can pick any number. Usually it is always safer to pick a number like 1. It's always safer to pick a number like 1. So we can pick a number like 1. Let's say we pick 1. That means that we are saying that x is equal to 1, or one of the factors of this particular polynomial is 1. If we pick 1, we are saying that x is equal to 1. And that means that x minus 1 that means x minus 1 is a factor. It's a factor. Do you know how we're getting x minus 1? Because we have x is equal to 1, x can be here, and this 1 can come here, and we don't have negative 1 go to 0. That means this is a factor. That's all we are trying to say there. That's all we are saying there. So if we pick 1, we are saying x is equal to 1. And if x is equal to 1, we are going to plug in. We're going to plug in into the expression. That means that we are saying that 2 x cubed, right? The x there, we are saying x is 1. So x is 1, and the cube comes here, plus 2. We're saying the x is also another 1, and then we square. Minus the x is 1, minus another 1, right? And then this gives us 2 into 1, right? Because 1 cubed is the same as 1 times 1 times 1. This is 1 times 1, which is 1. Plus, this is also 2. 2 and 1, because 1 times 1 squared is equal to 1 times 1, which is 1. Minus 1 minus 1, right? Now, we're going to get what? This times there, 2 times 1 is 2. 2 times 1 is also 2. Minus 1 minus 1. This gives us 4. Minus 1 minus 1. This gives us 3 minus 1. And it gives us 2. Now, when we plug it in, we have to get the whole thing to be 0. If it's not 0, so it's not a factor. Because it's not 0, it's not a factor. Any factor will make the whole polynomial 0. So since this doesn't work, we'll pick another thing. We'll pick another thing, like maybe we'll pick another one, maybe the reverse. If we pick 1, it doesn't work, pick maybe -1. If we pick -1, we are saying that x is equal to -1. And if x is equal to -1, we are saying that x plus 1 is a factor. That's what we are saying. X plus 1 is because if you have x equal to negative 1, the 1 can come here and get x plus 1 is equal to 0. And this is a factor. That's all we are saying there. That's all we are saying there. That's all we are saying there. All right. So if x is equal to negative 1 and we plug it in and we get the whole thing to be 0, if the whole thing is 0, then x is equal to negative 1 is a factor. So we're going to start 2 into x cubed. X is what? Negative 1. Cube it. Plus 2 into x equal to negative 1. You square it. Minus what's the x? The x there is negative 1. The minus came before the x. So minus and the x. And then another minus 1. Another minus 1. Let's find out what we are going to get. This one is going to give it negative 1 cubed. The same as negative 1 times negative 1 times negative 1. And negative 1 times 1 is positive 1. It's plus 1 times negative 1 times this negative 1. And then plus 1 times negative is getting negative 1. So we're going to get 2 into negative 1 plus 2 into 1. Because negative 1 times negative 1 is 1. Which is the same as 1 squared. Okay, don't forget. And then this gives us what? Negative into negative 1 minus 1. Now, 2 times negative 1 is negative 2. So we get negative 2. And this gives us plus 2. And this gives us plus 1. Because negative 1 times negative 1 is plus 1 minus 1. Why are we getting this negative 1? There's an invisible 1 here. All right. Now, this gives us 0. Why? Because this is what we owe and we paid. This plus 2. This is also what we paid and we owed 1. We owe. So all 0. So 0 plus 0 is 0. So it means that the x is equal to negative 1. The x is equal to negative 1 is a factor. So we're going to write this equation again, the polynomial again. We have a polynomial that says that, or an equation, which says that 2x cubed plus 2x squared minus x minus 1 is equal to 0. And we are saying that x is equal to negative 1 is a factor. Is a factor. And if that's the case, then we are saying x plus 1 is that factor. Is that factor. And then now we're going to divide. We have to divide it with a polynomial. So now we divide it. We divide it by the polynomial. Okay? So we are saying that what it means is that we are saying that the 2x cubed plus 2x squared minus the x minus the 1 is divided by the factor x plus 1. That's what we're doing. And if that's the case, remember our fractions. This is a divided by b. If we are dividing, the b comes out and the a goes in. Remember. So we're going to do the same thing here. Don't throw your fractions away. Now fractions is coming back to kind of haunt us. So these are the tricks that makes this topic or this video easy. It makes it easy, or the topic easy. So math equations are actually easy. So we bring the x plus 1 outside, and then inside will be 2x cubed plus 2x squared minus x minus 1, like that. Now what do we do? The first thing is to take this x and ask ourselves, what do we need to multiply by x to get 2x cubed? What do we need to do that? We need to multiply 2x squared by x, so that we 2x squared. If we multiply it by x, 2 times 1, an invisible 1 is 2, and x squared times x. Remember our indices, x squared times x. The bases are the same, so we add the exponent to x to the power 2 plus 1, and we get x to the power 3. Don't forget that. So it's 2x squared, and then when we multiply it back again, we are getting 2x cubed, and we subtract. When we subtract, we get 0. Now when we get 0, we drop this down, we get plus 2x squared here, plus 2x squared here, and because they are 2, we drop this one to here. We're going to get minus x, because whatever is here is 2, right? There are many, so that's why I'm trying to drop it there. Okay, I hope it helps. So now we're done with 0 here. We drop these 2 down here, because we are working with 2 things here. So now this x again, we're going to pick this x again, the x, and ask ourselves, what do we multiply by the x to get this plus 2x squared? And that's going to give us 2x. So that 2x times the x gives us what? This whole thing multiplied by just the x will give us okay. So let me backtrack a little bit. Let me backtrack so that I don't confuse you. Sorry for any form of confusion. Let me just backtrack just a little bit, and then we're gonna get it solved. So let's imagine that we're starting all over afresh. Okay, we're saying that we asked that what can we multiply by this x to get this 2x cubed? And we said it's 2x squared. We multiply by here and we get 2x cubed, right? We still have to multiply by this plus 1, and then we get plus 2x squared. Then we subtract. This This from this is going to give us 0. And then this and this is also going to give us what? 0. Because we're having 2x cubed minus 2x cubed. And then we're also having 2x squared minus 2x squared. And all brings us to what? All brings us to 0. All brings us to all brings us to 0. Then now, this is where we are going to be able to drop this. We're going to drop the minus x, and then we're also going to drop the negative 1 here. And then now, what do we multiply by x to get negative x? And it's minus 1. It's minus 1. So the minus 1 times x gives us minus x, and minus 1 times plus 1 will give you minus 1, and we get negative x. We're going to subtract. So negative x minus this minus x is going to give you minus x plus x, which is 0. So this is 0. And then we also have negative 1 minus another negative 1. Then we're going to get negative 1 plus 1, which is 0. So this is also giving us 0. So you can see that indeed the x plus 1 is a factor. So what are we getting? When we divided it, after dividing everything, okay, after dividing everything, what are we getting? We are getting this at the top. We're getting the quotient. Don't forget, this is called the quotient. Okay, that's the result. The quotient is the result. Okay, so we're getting 2x squared minus 1 is the result. And then this, if there was something here, is the remainder. Yes, and then this is usually called the divisor. The divisor. And then what is inside is called the dividend. The dividend. So we are able to get a quotient, which is it. So we are saying that to factorize. So if we want to factorize, so factorizing 2x cubed plus 2x squared minus x minus 1 is equal to 0. We said that we're able to get x plus 1 is a factor, and we're also multiplying it with a 2x squared minus 1. So when we multiply these two, we are going to get this whole thing here. So we have been able to simplify this polynomial by having this is our first factor, and then our two factors are in here. Our two factors are embedded in here, and then there you have it. And this is how we're able to solve anything that is of a higher term and to simplify it. I hope this helps. If it's not clear, please pause the video, go back a little bit, and I think that everything will be coming clear to you. Now we're going to move on to what we call simultaneous equations. Simultaneous equations. This is another section which is important. We look at simultaneous equation. Why are we looking at simultaneous equations? We are looking at a case where we will have to solve for two or more variables. So we want to what? Deal with two or more variables. Maybe we want to solve a question, solve problems. Okay, we are solving problems that have, they have what? More. Okay, they have two or more. Sorry, they have two or more variables. They have one, two or more. Have two or more variables. Okay, and that's where we use it. So, for example, we can say that we can have two variables. Okay, or we can have what we call greater than two variables. Okay, greater than two variables. So let's say that you're having a question like this. Let's say you have negative 3a plus 2b is equal to negative 5. You also have negative 2a minus 5b is equal to 3. When does this happen? Maybe you want to find out the cost. You want to do some computation between a table and a chair. The table could be the a and the b could be the chair. All right. So you and there's data that you have gathered for table and the data you have gathered for chair. All right. And then you want to see how you can be able to solve it. And you can be able to do that because there are two or more variables. If you have x minus 3 and I say solve this, it's easy. There's only one variable. The variable there is x. So it's going to be x equal to 0 plus 3 because this one is going to move in here, right? And the sign changes. It's easy. But if I say solve 3a minus c is equal to 0, it's difficult because this is an apple and then there's a cucumber. All right, it's going to be difficult to be able to bring them together. All right, so for simultaneous equations, there has to be two or more variables. There have to be two or more variables. And if there's two variables in question, then we are going to use two methods. There are two methods in using that to solve the problem. And the first one is known as the elimination method. The first one is known as the elimination method, and then the second one is known as the substitution method. Yeah, the substitution method. Now we want to deal with anything that is more than two variables, and there's something called the Cramer's rule. It's called the Cramer's rule, but we're not going to do that here. We'll treat this in our matrices class. When we do matrices, we're going to look at Cramer's rule in the way you're having three or more variables. You have an equation that has each equation has three different variables, maybe x, y, z. Each equation has three or more variables. You can have about 4 equations or 5 equations depending on what you are dealing with. For example, maybe a country has data on GDP. It has a data on inflation. It has a data on interest rates. There's a data on maybe net export or something like that. These are all variables, and based on that, you're going to have more than two variables in each data that you've gathered, and you have to be able to use simultaneous equation to solve it. And to do that, where there are more than two variables, you use what we call the Cramer's rule, where we're going to use matrices to find cofactors and all that to be able to arrive at that. But the focus of today's class, which is under equations, we're just going to be looking at two variables where we can use elimination method or the substitution method. So let's quickly look at the simultaneous equation. We have an example. We said that we have maybe 3a plus 2b is equal to -5. In fact, let me do a table. Sorry about that. Let me do a table where one column is the elimination method. One column is the elimination method, and then the other column will be maybe substitution. Maybe the substitution method. I hope it helps. Maybe the substitution method. So let's look at the same problem. We're having a problem here. The problem here is 3a plus 2b is equal to -5. It's equal to -5. And then that we call that equation 1. And then the second equation is -2a, -5b is equal to 3. And that's equation 2. And then the other one here is going to be 3a plus 2b is equal to -5. It's also equation 1. And then the next one is -2a minus 5b is equal to 3. And it's also equation 2. All right, same question, but we're going to use different methods to see whether we can arrive at the same answer. Now, with the elimination method, we want to make one side the same. You see how we have here to be 3. We want to make this side to either be 3 or the same number, So to do that, we can decide to say that equation 1, this is equation 1. We can say equation 1, we multiply by whatever is here, by this one. So equation 1, we multiply by -2. We multiply it by -2, and when we do that, multiplying equation 1 by -2 means that we're going to get -2 times the 3a. Can you see that? Plus another -2 times what? The 2b is equal to what? -2 times -5. Can you see that? And when we do that, we end up getting, this gives us -6a, and this gives us -4b, and then this gives us plus 10. And that will give us equation 3. Now, because we've done that, the next thing is to look at equation 2. Equation 2, we're going to multiply by 3. There's 3 here because we multiplied the equation 1 by -2. So we have to also multiply equation 1 by equation 2 by 3. So we're going to multiply equation 2 by 3. And when we do that, they're all going to be the same. So we multiply equation 2, this equation. We multiply it by 3. Why we multiply by 3? This number here. Whatever we do to the first equation, we do to the second equation. So we're going to multiply by 3. So we're going to get 3 times the -2a plus 3 times the -5b. Can you see that -5b is equal to 3 that we're multiplying by this 3 again? Okay, and what we're going to get, this gives us -6a, this gives us -15b, and it's equal to this gives us 9, and that gives you equation 4. Now, if we look closely, we can see that this -6a is the same as this -6a. You can see that. So what we do is that we can eliminate that because they are the same. And what do we do? If we say -6a plus -6a, does it go away? No, it becomes -6a minus 6a. Why? Because you owe this. You are still owing, so it's going to be double O. The only way it can go away is if you have -6a, if you have -6 plus 6a, where you owe and you have paid. All right. So to do that, we have to say that let equation 3 take equation 3 and do minus. We don't have to add. If we add, we are going to get something like this. If we add, this is adding. But if we subtract, it's going to be equation 3 minus equation what? 4. We're going to take this from that. Okay, so what are we going to get? We are going to get the negative 6a. We are going to write the 3 because it's equation 3 minus 4. So negative 6a minus, don't forget, negative 6a minus before what? This one here, which is minus 6a. Can you see that? Then the next thing is what? We plus minus 4b. Can you see that? Minus 4b minus this whole thing here, which is minus 15b. Can you see that? And we're also going to get is equal to, we're going to get 10 minus 9. Can you see that? Now we're getting minus 6a. This and this gives us plus 6a. And then this plus and minus becomes minus 4b. And then this and this gives us plus 15b. And we get 1. So basically, this goes to 0. This goes to 0. And then this is what you owe. You owe $4. And you have $15 in your wallet. So when you pay off, you're going to give you a change of 11b. So 11b is equal to 1. And basically, we're going to get 11b is equal to 1. And we divide it by 11. Divided by 11, b becomes 1 over 11. And that gives us equation 5. Now, we can now put 5, the equation 5. We can now put this 5 into what? Any of them. We can put this 5 into 1. So we can say put 5 into 1. So what is 1? 1 is 3a plus 2b is equal to negative 5. Can you see that? This is 1. Now the b is given. So 3a plus 2 into the b, which is 1 over 11, is equal to negative 5. And we can solve for a. I know you can do that. So that's how you do the elimination method. But if we want to look on how we're going to solve for elimination for the substitution method, we can, for substitution method, what it means is that you need to make one of the variables a subject. So let's say from 1, we can say make a the subject. Make a the subject. And to do that, we're going to get 3a. You're going to get 3a is equal to negative 5 and then minus 2b. This one goes there. Minus 2b. And then you're going to get a is equal to minus 5 minus 2b divided by 3. And then because we know this becomes equation 6. Now we can go and now put this 5 back here so that we can look for a. So a becomes negative 5 minus 2 into 1 over 11 all divided by 3, and we can be able to look for b. So that's the elimination method, and that's the substitution method. Whichever one works for you, stick to it. But there are certain problems that is so obvious that you have to use the elimination method. So that's why it is important to know, to have a feel of both methods. Now we're going to look at change of subject. So we're going to look at the equations where you are being asked to look for variables to stand alone. And then I think we'll be left with inequalities and variations, and I think we bring our lecture to a close. I hope you're enjoying this lecture so far. If you haven't yet subscribed, please do us a favor to subscribe so we can be able to grow this family together, and share this video to as many people as possible. If you're already a subscriber, we want to thank you and appreciate you for supporting our channel. Now we're going to look at change of subject. What does it mean? We have equations. Maybe you have like an equation t is equal to the whole square root of L over G, and we are being asked to look for G or make G stand alone. You can tell it to look for G or make G stand alone. And how do we do that? We'll square, right? So to do that, we'll square both sides, right? So that we can eliminate the what? We can eliminate the square root. So square both sides. And when we do that, we end up getting t, squaring it. It's equal to the square root of L over G, squaring it. And then we're getting t squared is equal to the inside is L over G, and the square root is half. Can you remember from indices? The square root is equal to the power half. Power of half. Don't forget that. So the inside is L over G, and the square root is this half here. But don't forget the square that is outside it. Now we are going to get t squared is equal to L over G the half multiplied 2. Do you remember from our indices, we did say that, if you have an to the power n, which is the same as a to the power n times m, and that gives us a to the power nm. Don't forget that. And when we do that, we end up getting L over G, the half times 2. This will cancel out, and we get L over G, basically. Now, it means that we're having t squared on the left-hand side. Don't forget, t squared is equal to this L over G. And then we cross multiply. Or how do you write t squared as a fraction? Because the right-hand side is a fraction. You can see this is a fraction. So we also have to write this as a fraction. All right? And to do that, t squared is the same as divided by 1. Can you see that? So it's going to be t squared over 1 is L over G. And when we have an equal to sign between two fractions, don't forget, an equal to sign between two fractions, we cross multiply. We've shared this on our short videos as well. So t squared times G is equal to 1 times L. 1 times L. And you get t squared G is equal to L. And then we're looking for G. So we divide it by t squared, and we get G is equal to L over t squared. This is what we mean by change of subject. Okay. Another question is we could be given E is equal to MC squared, and they can say we should look for what? See, we can be told to look for make C the subject. So what do? We can see that the C there is already attached to M. So let's find a way to eliminate that. We eliminate by dividing it by M and dividing it by M. And we have E over M equal to MC squared over M. And we cancel this out. We get E over M is equal to C squared. And when we have that, we're having E over M is equal to C squared. And basically, we are going to get square root. We square root both sides. We square root y. So we can remove the square root both sides. So we're going to E over M, take a square root, is equal to C squared, take a square root. Square root of E over M is equal to the inside is C squared, and the square root is half. Don't forget that. You get the square root of E over M is equal to C squared times the half, because of the rule an to the power m is the same as an times m, like this, which is c squared times half. This cancels and we get c to the power 1. So e over m, the square root of that is c. So our final answer is, therefore, our c is equal to the square root of e over m. And that's what change of subject. Now let's quickly look at inequalities, which is also part of kind of equations as well. We're going to look for inequalities. So inequalities is basically all the equations that we have studied, except that the sign there is not equal to sign. All right. So inequalities is all that we have studied. Let me write it down. All that we have studied. All that we have studied. All that we have studied in equations so far. All right. All that we have studied in equations so far, but has what? Has no has no equal to sign. What does it have? It has these signs. It possesses these signs. Has these signs. What are the signs? They are as follows. Either it's greater than, this is known as greater than, or it has what we call greater than with an equal to sign under it, which is greater than. It means greater than or equal to, or greater than and equal to. Okay. Or it could also have a less than. It's called a less than. You can have a less than, or what's it called? Or a less than with an equal to sign, or less than and equal to. So that's basically the difference. So I can give you remember when we talked about the algebraic expression, we had 7x squared minus 3x minus y minus 2z, all right, plus 4p minus 5x. If we can put a less than 0 there, like this, it makes it an inequality. Or we can have a 7x squared plus 4p less than or equal to 0. Or we can have a y greater than negative 2x minus 1/4, or minus 1/4. Or we can have a y greater than or equal to negative 2x minus 1 over 4. This is what makes everything unequal, but the rules are the same. The rules are the same. You remember, if you have x minus 3 is equal to 0, if you're looking for x, it's going to be x is equal to 0 plus 3 because this has to cross. So same way, if you have x minus 3, let's say greater than 0, it's going to be the same. It's going to be x greater than 0, and this is going to cross the equality sign, the inequality sign. This is called the inequality. Inequality. It's not an equal to sign. Equality sign. The moment it crosses, the sign changes to plus 3. Don't forget that. So it's the same. The only difference. So let me go to the next page and write it big. The only difference is that when you divide by a negative number, the inequality sign changes. The only difference, okay, is when we divide by negative value, when we divide by a negative number, inequality sign changes. The inequality sign changes. Inequality sign changes. So let's look at a quick examples. So let's look at, let's say we have negative 3x, for example, is greater than, let's say 9, for example. All right, what are we going to do? We're supposed to look for x, right? So we divide both sides by what? Negative 3. And when we divide both sides by negative 3, remember the sign is going to change. Okay, so that we are going to get what? This cancels out. We're going to get negative 3x divided by negative 3. Because we divided by negative number, the sign changes to less than. We get 9 divided by negative 3. So that's the only difference. So x now becomes less than 9 over negative 3, not the same greater sign that we started with, which gives us negative 3, because this goes into 1 and this goes here 3. The common factor is 3. So x becomes less than negative 3. Becomes less than negative 3. And if you are asked to put it on to find the solution set, then it's going to be x such that x it belongs to all real numbers. Remember, every number is a real number, and x is less than negative 3. This is a solution. This is called a solution set. And the number line, to put it on the number line, this is a number line. Plotting it on the number line. Let me write that. To plot on a number line. Plot on a number line. We're going to have this. So we know that 0 is always at the center. This side is negative numbers, and that side is positive numbers, right? So this is a negative number, negative 3. Let's imagine the negative 3 is here. Remember, can you see the sign? This less than sign. The elbow is showing me this way, right? So since the elbow is onto the left, we're gonna draw a circle. We're gonna draw a circle on top of this 3 and then direct it to this way because the elbow is to the left. And then we leave it as is. So this is how we're going to represent it. If it was x less than or equal to negative 3, we would have shaded inside. It would have been this. And then we'll draw it that way like that. So if we had, let's say, negative 3x greater than and equal to 9, and we divided here by negative 3 and divided by negative 3, the sign will change to negative 3x divided by negative 3 to change to less than and equal to. Whatever sign you have is the opposite. 9 over negative 3. Like this, and you're going to get x is less than or equal to negative 3. And when we plot this, the negative 3 is still here. We draw the circle. The elbow is to the left, but we're going to shade inside to show that it includes the value negative 3. It includes the value negative. So that's basically the difference. So let me quickly put that out there. So if you have less than and you divide by a negative number, the sign changes to greater than. If you have less than and equal to, divide by a negative number, the sign changes to what? Greater than or equal to. If you have greater than and divide by a negative number, sign changes to this way. If you have greater than or equal to and you divide by a negative number, it also changes to less than and equal to. I hope this helps. So I believe the last thing, so that we can bring the curtains down to this comprehensive lecture, so that all that we need to know about equations is that we are going to look at what variations. We are going to look at variations, and then we bring the curtains to equations down. If you haven't yet subscribed to our channel, please do us a favor by subscribing so that we can grow this family together. If you're already a subscriber, we want to appreciate you for helping support the channel. So we are on variations. And we have 3 types. There are 3 types of variations. We have what we call the direct the direct variation, we also have what we call the inverse, the inverse variation, and we also have what we call the partial variation. With the direct variation, you hear the words such as directly related. Something is directly related or directly varies. Is directly related or directly proportional in the question. You hear the words like that, terms like that. You also hear something like it varies directly. Varies directly. The moment you hear the word varies is the sign. So varies or variation symbol is this. Or so, not the infinity sign, like this. It varies is like this. It varies like that. So a direct variation will have what a constant. Will have a constant. It has, let me write here in different color. It has one constant. Okay, so if they say A varies with B, we are saying that A is equal to a constant times B. That's what we're saying. Varies. A constant should be introduced. If A varies with B, we are saying A is equal to that constant multiplied by the B, because it varies proportional with that variable. So A becomes KB like this. Now, on the other hand, if we have an inverse, you hear the words inversely related, or inversely proportional, or it varies inversely. All right, so we're still going to have that same symbol, and when that happens, it means we have we have one constant. It also has one constant, but it's going to be with a fraction. So we're going to have, if it says A varies inversely, it means A is equal to a constant multiplied by the inverse of the variable. In this case, maybe A inversely with B is going to be 1 divided by B. You rotate it, you do the reciprocal of B, and then you're going to have A is equal to K over B, like that. But with partial, if it's partially related, if they are partially related, okay, then there are two constants. Maybe K1, K2, and it varies with what? There are two constants and a what? An inverse. And an inverse variation. So we're going to get 1 over B. So it's going to be something like this. It's going to be K1 multiplied by the K2 multiplied by the inverse of that variable. So you're going to get K1, K2 over B, like that. A is equal to A. If A varies, right, you're going to get it that way. I hope this particular thing helps. So thank you for tuning in with us and joining our channel and helping us go walk through all the things that we need to know about equation. And don't forget, we did talk about algebraic expressions. We went into equations and looked at different types of equations. And then we started with the linear equation, looking at the slopes and gradient and finding the equation of a line, and then how we can compare slopes of a line and then slopes in curves or nonlinear expressions, where we apply the techniques of differentiation. And then we also continued by looking at polynomials. Anything that is of the degree 1, how do we look at it? We look at the quadratic equation, and with the quadratic equation, there are 3 methods. The first method was factorization. We looked at focusing on 2 ways on how to use the factorization method. If the coefficient of x is 1, there's one way we can quickly do that. But if it's not, then we go through the normal factorization process. The second method was the quadratic formula, where we look for the values of the a, b, and c and plug it into the formula. The formula needs to memorize. X is equal to minus b plus or minus square root of b squared minus 4 is all divided by 2a. And then we looked at the third method. The third method was the completion of squares, where if the first and second method fails us, then we are stuck with arriving at applying the completion of squares, the completion of squares method. And then we moved on. We moved on from there, and we looked at how we can apply division of polynomials to be able to factorize an expression that has a degree 3 or 4, and how we can be able to do that. We were able to successfully look at that, and then after doing that, we continued by looking at what simultaneous equations, where we are given equations that have more than two variables, and so we use 2 methods to do that: elimination method and substitution method. And then we also looked at, we couldn't look at it more than 2 variables. We said it's not related to the class. We will treat that when we get into matrices later sometime. And then we came into looking at change of subject, where we are given an equation, but we need to make a variable stand alone, or look for that particular subject. And we came to the inequalities. So inequalities can be applied. We can apply all the rules of equations in inequality, and it's the same thing. The only thing that changes is when we divide by a negative number, and then the sign changes. We can kindly pause the video, go back, and you see how those sign changes. And we finally close with this topic called variation. All right, I'll come to you another time. Please take care and please subscribe. Thank you. Bye.